Bernoulli's law of large numbers. So today we are going to consider the law of large numbers, and it is particularly the Bernoulli's law of large numbers. As the name suggests, we are conducting a random experiment which is a Bernoulli trial. That is, the only possible outcomes for this random experiment is either a success or a failure. That is, the occurrence of a specific event or the non-occurrence of event. So there are only two outcomes. Either it could be a success or a failure. So for the Bernoulli's law of large numbers, we consider the probability of success as P, and we also assume that this P is same. This probability of success is same for all the trials that we are going to consider. And we denote small letter n as the number of trials of the experiment, and xn denotes the number of successes in n trials. So, if all these things are considered, then the Bernoulli's law of large numbers states that for any epsilon greater than 0, probability of mod xn by n minus p less than epsilon tends to 1 as n tends to infinity. So, here one thing what we have to note is xn denote the number of successes in n trials. That means this xn follows a binomial distribution where xn follows binomial with n and p as parameters. Now we are going to move on to the proof. So to prove this inequality or to prove this limit, the Bernoulli's law of large numbers, what we are going to do is, we have already told that xn follows binomial np. So since xn follows binomial np, we know expectation of xn is equal to np and variance of xn is npq, where q is equal to 1 minus p, which is the probability of the failure. Now, what we need is probability of mod xn by n minus p. So, our variable of interest is xn by n. So, we need to find the expectation of xn by n. Expectation of xn by n is equal to 1 by n expectation of xn. That we know because we know expectation of ax, where x is a random variable and a is a constant, is a into expectation of x. Also we know that variance of ax is equal to a square into variance of x. Yes. So this is equal to 1 by n expectation of xn. So 1 by n into np, which is equal to p. So the expectation of xn by n is p. Now what we need is, we need to find the variance of xn by n also. So variance of xn by n is equal to 1 by n square variance of xn. And we know the variance of xn is npq, which is equal to npq divided by n square, which is equal to pq divided by n. Now what we are going to do is, we know the Chebyshev's inequality that we have already discussed. So the Chebyshev's inequality is like this: probability of mod xn by n minus its mean, the mean of xn by n, that is p, less than t into sigma. Sigma is a standard deviation. So we know what is the variance of xn by n. So the standard deviation will be root of this into t sigma. Instead of sigma, we can write root pq by n is greater than or equal to 1 minus 1 by t square. Now what we are going to do is, we know the Bernoulli's law of large numbers, and the left side of this Bernoulli's law of large numbers can be equated to this equation. So from there, I'll get T into root PQ by N is equal to epsilon. T into root PQ by N is equal to epsilon by equating these two. So from here, I will get T is equal to epsilon divided by root PQ by N. Also, T square is equal to epsilon square divided by PQ divided by N, which is equal to N epsilon square divided by PQ. Yes. Now, we know this inequality and we are going to substitute the value of T or value of T square in this right hand side. So what happens is probability of mod xn by n minus p less than, we know T is equal to epsilon divided by root PQ by n. So if I am going to substitute this T into this equation, then what is left is epsilon, because root PQ by n is there in the denominator as well as in the numerator. So it will go cancelled and what is left will be epsilon is greater than or equal to 1 minus 1 by T square. That is 1 minus 1 by N epsilon square divided by PQ. So which is equal to, this side is equal to 1 minus PQ divided by N epsilon square. Now we have already told that this random variable or this random experiment has only two outcomes, that is the success and failure. So if P denotes the probability of success, then Q denotes the probability of failure. So the maximum value this P and Q takes is when both P and Q are both 1 by 2. So we are going to substitute this value P and Q by the maximum value of P and Q, which is equal to 1 minus 1 by 2 into 1 by 2 divided by N epsilon square. The maximum value is greater than or equal. This value is greater than or equal to this. So this value is anyway greater than or equal to maximum of PQ. For any choice of P and Q, this probability is greater than this, the right hand side. So we are going to substitute it by 1 by 2 and 1 by 2. So this is equal to 1 minus 1 divided by 4n epsilon square. So I can write it as probability of mod xn by n minus p less than epsilon is greater than or equal to 1 minus 1 by 4n epsilon square. So from here, we have an n in this denominator term. Now, as n tends to infinity, this is probability of mod xn by n minus p less than epsilon, which is greater than or equal to 1 minus 1 by 4n epsilon square. So if this n is tending to infinity, this is like 1 minus 1 by infinity. And we know this term will tend to 0. That is, this whole term will be equal to 1 or will be greater than or equal to 1 since this inequality holds. But we know this is a probability. Since this is a probability, this value cannot be greater than 1 because 0 less than or equal to p less than or equal to 1 is what we know. The probability value is between 0 and 1. So this is a probability and this is greater than or equal to 1, or this tends to a value that is greater than or equal to 1 means this value tends to 1. So, probability of mod xn by n minus p less than epsilon tends to 1 as n tends to infinity. So this is the complete proof where we have taken xn to be a binomial random variable where xn is the number of successes in n trials, and we have found the expectation of xn and variance of xn, and then we have found the expectation of xn by n and variance of xn by n, which we got as p and pq by n. Then we are going to use the Chebyshev's inequality. Then from the Chebyshev's inequality, we find what t is by equating it with the Bernoulli's law of large numbers, and we will get t in terms of epsilon, and from there we are going to substitute the value of t in terms of epsilon into that Chebyshev's inequality, from where as n tending to infinity, we will get probability of mod xn by n minus p less than epsilon tends to 1. So this is the proof for the Bernoulli's law of large numbers. I hope it is clear. So if you have any doubts, you can comment it or you can ask. Thank you.